Welcome back. Right, so in the last Nearpod, we learned the formula for finding the inscribed angle given the arc, or the arc given the inscribed angle. As a reminder, the inscribed angle equals half the arc. Let's use that equation if we're looking for the inscribed angle, since inscribed angle is already isolated. Or we can think of it as the arc is 2 times the inscribed angle. Let's use this formula if we're looking for the arc given the inscribed angle. All right, so now let's solve each of these. First of all, we want to find angle PRU. So we'll use the first equation. Inscribed angle equals half the arc. All right, so now if we look at here is angle PRU, and if you have any trouble, just go to the vertex and then follow the angle out from the vertex, and you can see what the intercepted arc is. So the arc is the part of the circle that's between the 2 sides of the angle. So that means that angle PRU is equal to half of arc PU. We know the measure of arc PU, that's 118 degrees, so that means that angle PRU is half of 118 degrees, or 59 degrees. Now let's find the measure of angle arc SP. All right, so arc SP goes from S until P, right? Short way around the circle because it's a minor arc. All right, just go to the end of the arcs and just follow back to the angle. We see this is the inscribed angle for that intercepted arc. So now we're looking for the arc given the angle. We're going to use the second formula. So arc SP is equal to 2 times the inscribed angle, which is angle PRS. Right, and angle PRS is 27 degrees, so that means that arc SP is 54 degrees. And there we go. And we got the first one done. Let's do another one. I think I have 6 pages here. And let's see if this one was not in your notes, but how about the next one? So as it changes the page. This one, these are both in your notes. Right, so here, in both cases, we're looking for the inscribed angle. So we'll use the formula inscribed angle equals half the intercepted arc. Right, so that means, and there's no letters on the first one. I guess we could put some letters here. A, B, and C. All right, so X there, or angle ABC, is going to be equal to half of arc AC. Since arc AC is 108 degrees, that means that the angle is equal to 54 degrees. And there we go. That one's done. Not too difficult. Now this one we have to do a little bit of work. All right, so now first of all, notice that chord RQ is congruent to chord PQ. Now and do include the explanation on this one, all right, so that you learn how to justify an answer, because this one will require it. Since segment or chord RQ is congruent to chord PQ, then we know that arc RQ has to be congruent to arc PQ, right? Because congruent chords have congruent arcs. We know the measure of arc RQ, that's 125 degrees. So therefore, arc PQ is also equal to 125 degrees. Right, now we need to find the measure of the last arc in the circle, PR. Right, so together the three arcs equal the whole circle. So PR is going to be equal to 360 degrees minus the other two arcs, minus RQ and PQ. And we do need parentheses there because we're subtracting that whole quantity. That means that arc PR is 360 minus 125 plus 125, which is 360 minus 250, or 110 degrees. All right, so now we know the measure of arc PR. I kind of ran out of room down there. I'll just put it up here. The measure of angle RQP, PQR, or X there, is going to be equal to half of arc PR, because that's the intercepted arc. Right? If we follow the angle out, this is the intercepted arc between the sides of the angle. So that means that X is equal to half of 110, or 55 degrees. And the equal sign's looking kind of funky there. We'll just do that. Of course. You know how much it likes to ungroup my stuff. There we go. All right, and so we've solved this one. So I know it's the first one didn't require much work at all. The second one, you've got a little bit of space on the side there. Try to add in this and this. Okay? All right, let's try the next one. This is going pretty quick. And it's coming up any moment. Let's see if this one's in your notes too. This one is in your notes. All right, so, and it still says notes up there. So remember, we're looking here for the inscribed angle. We know what the intercepted arc is. If we follow the sides of the angle where it says 2x plus 1 to the edges of the circle, we see that PR is the intercepted arc. So therefore, angle PQR is equal to half of arc PR, because the angle is half the arc when the vertex of the angle is on the circle. All right, so now let's replace PQR and PR with the values we have. All right, so PQR is 2x plus 1. And PR is 96. So it's always easiest if you just isolate the thing you're looking for. Since the angle has the variable, let's use angle equals half the arc. All right, so now we just solve it like an equation. We just have to simplify 1/2 times 96. So 2x plus 1 is equal to half of 96 is 48. Right, and now just solve for x. Use inverse operations. First we're going to subtract the 1, because we want to get the x on one side and the number on the other side. So 2x is equal to 47. And then divide by 2. You can either leave this as x equals 47 halves. Right? That's an exact answer. Or, since this is a terminating decimal, you could put it in as 23.5 degrees. Actually, sorry, just 23.5. X is just a value. It's not until we plug it in that we actually get a measure of an angle. Right? And if we multiply it, if we want to do a check, the check is optional in your notes. Let's just do the check and check it back, sure. Make sure it works out. All right? You might think, I don't know if I got the right answer. I got a fraction, or decimal. All right, so now we know that the angle is going to equal 48 degrees, right? Half of 96. So 2 times, I'm going to stick with the fraction there. It's a little easier. 47 halves plus 1 should equal 48. And if you're not sure that half of 96 is 48, right, you can always use a calculator. The 2's will cancel, and so then we have 47 plus 1 equals 48, and that does indeed check out. And you don't have to put the check in your notes. I just wanted to show you that, yep, we got the right answer. That checks out. All right, let's solve the next one. You've only got 2 more in your notes. Let's see if this is one of them. The one coming up. This is one in your notes. All right, this time we are looking for the arc, because the arc has the variable. So remember, the arc, and you don't have to write this part down because it's in your notes already, right on that same page. The arc is equal to 2 times the inscribed angle. It's either right on the page or you wrote it on the page. I think you had to write it on the page. All right, so now let's use that formula. So the arc, 5x plus 2, is equal to 2 times 66. We don't have any letters here. I could add them in, but I added them on the other problem, so we'll just write it in like this. So we have the formula there. You have the formula already in your notes, so I think we'll be okay. All right, so now we're just going to multiply 2 times 66. So 5x plus 2 equals 132. Now we want to isolate x, so we'll subtract 2 from both sides. 5 is looking a little bit like a 6. 5x equals 130. Divide both sides by 5, and x is equal to 26. Right? Because 13 divided by 5, that would go in twice, and we'd have 3 leftovers, and then 5 would go into 36 times. Right? Right, and this one is done. That's all there was to this one. All right, so it's pretty easy to work with inscribed angles. Now sometimes you have to do a little bit more work. Like maybe you got to solve for the arc first before you can even find the angle, using some of the properties we've learned, but that's okay. This might be one of those problems. All right, so this one is in your notes, and this is the last one in your notes, and there is some space to the side, to the right. I think you can fit this one in. I do want you to add in this part. It's not too much to write, so, and it explains our problem. So AB, and we should have that above it, but I can't type that. AB is a diameter. And how do we know that's a diameter? Well, it goes right through the center of the circle. All right, so that means that arc, and it just kind of stops, but arc ACB equals 180 degrees, right? Because we know that a semicircle, a diameter divides our circle in half, and then we have a semicircle. Right? So this whole distance here is 180 degrees. We, however, need this measure right here, right? Because that's the intercepted arc for our angle. And if we follow the sides of the arc back to the vertex, we see, yep, this is our angle right here, and that's our arc. All right, so we know that arc AC equals 56 degrees. Together, arc AC plus BC is 180, so therefore BC has to be equal to 180, the whole circle, minus AC. Right? And we can just write AC, bring out AC here. All right, so that means that arc BC is 124 degrees. We're looking for the angle. We know that the angle equals half the arc. I'm going to write that down. You don't have to write that down, but the angle equals half the arc. All right, so that means that x there equals 1/2 of arc BC. Since arc BC is 124 degrees, that means x, or the measure of angle BAC, is 62 degrees. And there we go. That's the last one in your notes. And we can pause so that you can write that down. I don't know if there's any more problems that are not in your notes, or if that's the last one, period. I'm trying to remember. No, I have one more. I think this is the last one. And this is kind of an interesting problem. And I didn't put it in, but that's all right. Oh, I did put it in. We just didn't label it. All right, so this is the last one in your notes. Notice we have that picture right on top there. Let's label it. And I think we may have labeled it, you know, vertex and things like that, labeled the parts, but that's okay. Let's get the angle measures in. So next to arc AB, put in Y. Next to arc BC, put in 75. And next to arc angle ABC, put in 95 degrees. And we want to solve for Y. All right, so we already know BC. Together, arc BC plus arc CDA plus arc AB equals the whole circle. It equals 360 degrees. Right? We already know BC, that's 75 degrees. We know arc CDA. We don't know arc CDA yet, but we're going to find it. And we don't know arc AB yet. But that's what's going to be left. Let's first find arc CDA. All right, so we know the measure of angle ABC. If we follow the angle out, we see that arc CDA is the intercepted arc. All right? And by the way, if you need more space, you can always add a piece of paper. I can always put it into your book for you. All right, so that means we know how to find the measure of arc CDA. Arc CDA, so we're looking for the arc given the angle, and we know the arc is 2 times the inscribed angle. So since the measure of angle ABC is 95 degrees, the measure of arc CDA is twice that, and that means arc CDA is 190 degrees. So now we can just replace arc CDA with 190, and now let's solve for AB, which is Y. Actually, let's replace this here with Y. So 75 plus 190, that'll be 265. Subtract 265 from both sides, and that means Y is 95 degrees. And there we go, and we have solved it. All right, so sometimes you have to do a little more work. You have to remember things like the sum of the angles in a circle is 360 degrees. Or if a circle has congruent chords, the arcs that are created are also congruent. Well, that's the end of this video. We're going to see more with inscribed angles in the next video. So come back to the next Nearpod and you'll see that one. All right, so bye for now. Thanks for watching.